Okay, so we're going to finish going over 1.6. Yesterday we did midpoint. Today we're going to go over the distance. In a coordinate plane, the distance d between 2 points, x1 and y1 and x2 and y2 is this formula. Add this to the lists of formulas that you guys have. Remember, you have a quiz on Monday. So the distance formula is the square root of x2 minus x1, and that's squared, plus y2 minus y1, and that's squared. We're going to do examples using this formula in the next.
Wait, so did we have to do the homework?
Yes.
But if we're still doing the...
So determine whether FG is congruent to JK. So let's find the points of F and G. So the coordinate of F would be, remember, X is first, so you're going to the right one and then up 2. So it would be 1, 2. And then G would be, what's G? 5, 5. So let's say that F is our first point. So 1 will be x1, 2 will be y1. And then G is our second point, so we have x2 and y2. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So what is x2? 5 minus, what's x1?
1.
Plus, what's y2?
5.
Minus, what's y1?
2.
2 squared.
Is that d, is it always going to be a d, or can it be any other?
We're measuring the distance, so I'm just putting the d there so you know that that's what we're trying to find. But you don't have to put it. So, what's 5 minus 1? 5 minus 2? 4 squared.
16.
Plus, what's 3 squared? 9. So the square root of 16 plus 9 is the square root of 25, which is 5. So that's the length of FG, this one. It's 5.
That's just one length.
That's just one length. So now let's find the length of J and K. So what are the coordinates for J? Remember, we do the x first, so it'd be -4 because we're going to the left 4. And K is -1, -3. So we do, let's take J as our first point. So -4 will be x1, 0 will be y1. K is our second point. So -1 will be x2, and -3 will be y2. So we do the square root. So x2 is -1 minus -4 squared plus y2 -3 minus 0 squared. So what is -1 minus -4? Right here. Because the formula tells us to subtract.
-5.
So remember, you make this a big plus sign.
So it is.
So negative 1 plus 4 would be 3. Squared plus negative 3 minus 0, negative 3 squared. So 3 squared is 9 plus 9. This would be the square root of 18. Is the square root of 18 equal to 5? No, so then FG is not congruent to JK. Because they're two different lengths. Yeah, that's a G, sorry. So minus 1 squared. This will be the square root of what's negative 5 minus negative 2. Remember, you make this a big plus sign. So negative 5 plus 2, negative 3. Squared plus 5 minus 1, 4 squared. So what's negative 3 squared? 9. 3 squared is 9. Plus 16. So the square root of 25, which is equal to 5. So this is the length of EF. So now let's find GH. So what is the point of G? Negative 1, negative 2. And what's the point of H? 3, 1. So we have the square root of x2. Let's say that this is our x1, y1, x2, y2. So x2 is 3 minus x1, so negative 1, squared plus, that's parentheses. So plus y2, which is 1 minus negative 2 squared. So what's 3 minus negative 1? So 4 squared plus 1 minus negative 2, 3 squared. So 16 plus 9, which is equal to square root 25, which is 5. So GH is equal to 5. So if GH is equal to 5 and EF is equal to 5, what does that mean? They're congruent. So GH is congruent to EF. In a right triangle, the two sides that form the right angle are the legs. So if we have a right triangle, this side and this side form a right angle. So these would be the legs. The red ones would be the legs. The side across from the right angle that stretches from one leg to the other is the hypotenuse. So if this is the right angle, the side that is opposite of it is the hypotenuse. So in the diagram, A and B are the lengths of the shorter side, so A and B are the legs, and C is the hypotenuse. In any right triangle, A and B will be the legs, and C is the hypotenuse. So in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So you're going to add this formula to your list, okay? So a squared, so you take the length of one leg and square it, plus the length of the other leg and square it, and that will give you the hypotenuse squared. And this is the Pythagorean theorem. So we're going to use the distance formula and the Pythagorean theorem, the one we just did, to find the distance to the nearest tenth from D to E. So let's do distance first. What is the coordinate of D? 3, 4. It's given. And E? -2, -5. So 3 will be our x1, 4 will be our y1, -2 will be our x2, and 5 will be our y2. So we have the square root of, what comes first? -2 minus 3 squared plus, what's next? -5 minus 4 squared. So we have -2 minus 3, -5 squared plus -5 minus 4, -9 squared. So 25 plus 81, which would give us the square root of 106. So this is the length of DE. We're just going to leave it like that because we don't have a calculator. So now let's find the length of DE using the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So let's look at the triangle. How do we know what A is? We can see it, right? A is 1, 2, 3, 4, 5. A is the length of this, so it's 5. So A is 5. What's B? 1, 2, 3, 4, 5, 6, 7, 8, 9. B is 9. You know that this point is 5 below the x-axis, and this point is 4 above, so 4 plus 5 is 9. So if we have 5 squared plus, what was B? 9 squared is equal to c squared. We don't know what c is yet. So 25 plus 81 is equal to c squared. To get c all by itself, we take the square root of both sides. Well, we know 25 plus 81 is 106. So we take the square root of both sides. That cancels out. So we're left with square root of 106 is equal to c. And c is the length of DE.
Which is what?
So this is the same as this. So this is just two different methods of finding the same length.
Doesn't C always have to be the one side?
Yes. C is always going to be the side opposite of the right angle. So if this is the right angle, C is going to be the one opposite.
And it doesn't matter what side A is on.
Right. You could call this one B and that one A. It doesn't matter. Any questions about this side? The next two slides are just what we just did. Method 1 being the distance formula. It's the same problem. And then method 2, the Pythagorean theorem. So use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from R to S. So let's draw it out. So R is 3. So we go to the right 3 and up 2. And what would the height be? 3. So we take 6 squared plus 3 squared is equal to c squared. 6 squared is 36 plus 9 is equal to c squared. 36 plus 9 is 45 is equal to c squared. Take the square root of both sides, and you get square root 45 is equal to c. So see, this answer and this answer are the same thing. Because we're finding the same length. We're finding the length of SR, just with two different methods. Which one do you guys like better, Pythagorean theorem or the distance formula? So this one is the Pythagorean theorem. Okay, last example. Use the distance formula in the Pythagorean theorem to find the distance to the nearest tenth. So let's draw it out. We have r is -4, 5, so we go to the left 4, and then up 5. And s is 2, -1, so we go to the right 2, and down 1. So this is r and s. We're trying to find the length of rs. So let's do the distance formula first. Let's call r first point, so we have x1 and y1, and s will be our second point, so we have x2 and y2. So what's the distance formula? The square root of, what comes first? x2 minus y1, x2 minus x1, so 2 minus -4 plus y2 minus y1 squared. So what is 2 minus -4? Remember, this becomes a big plus sign. So 6 squared plus -1 minus 5. -6 squared. So we have the square root of 36 plus 36, which is equal to the square root of 72. Yeah. So this is the distance using the distance formula. Now let's find the distance using the Pythagorean theorem. So we're going to make this a triangle and drop it straight down and straight to the right to make it a right angle. So let's call the base A and the height B. What would the base of this triangle be? We're going over 1, 2, 3, 4, 5, 6. 6. Because right, we're to the left of the graph 4, and then to the right 2. So we add those and we get 6. So A is equal to 6, and B is, we're going up 1, 2, 3, 4, 5, 6. So B is equal to 6. So A squared plus B squared is equal to C squared. 6 squared plus 6 squared is equal to C squared. So we have 36 plus 36 is equal to C squared. 72 is equal to C squared. Take the square root of both sides, and you get C is equal to the square root of 72. Any questions?